Okay, everyone, we're going to continue with the Pythagorean Theorem today. I bet you loved it last day, so exciting to continue it today, I'm sure. Alright, we're going to do a question that's, well, exactly like we did last time, and you might be saying, why are we doing that? You'll see in a second. So I'll do this fairly quickly. You see we have a right triangle, and we know the two distances, the sizes, the lengths of the legs, and we want to know the length of the hypotenuse. So remember your formula for the Pythagorean Theorem, a squared plus b squared equals c squared. And remember also, super important, the c must always refer to the hypotenuse. So if we do this question, these are our legs, of course. A can be either one of the legs. I'll use the 7. So 7 squared plus b is the other leg. Well, the other leg is 6, so 6 squared equals c squared, you could put. Or, since they've got an x there, we could also put x squared. Then we do this. 7 squared, 7 times 7, 49. 6 squared, 6 times 6, 36, equals x squared. 49 and 36, we add those together, you get 85. Is that your answer? No way, that's way too big. You have to undo that squared. So the opposite of squaring something is square root. When you take the square root of x squared, well, the square root and the squared cancel each other out. You're just left with x. I'm just going to flip it over to the other side. And square root of 85. Time to pick up your calculator. You should know how to estimate that, right? You know it's a little bit more than 81, so it should be 9 point something. And in fact, the square root of 85 is 9.2. So there's your answer for that. Nothing new, exactly like we did last day. So I have a question for you. What's different about this question that we're about to do here? It's a right triangle. There's two sides we know. We're trying to find the third side. Why is this different than everything we did last day? Because in this question, you already know the hypotenuse. You're trying to find one of the legs. In this question up here, you knew both legs, 7 and 6, and you're trying to find the hypotenuse. Here in this question, you know the hypotenuse, and you're trying to find one of the legs. So let's think about this here. If you already know the hypotenuse, what do you know about this answer here? It can't be more than 10, can it? Because this is the biggest side. The hypotenuse by definition is the biggest side. So when we get our answer, we better make sure that we get an answer that's less than 10. Alright, how are we going to end up with an answer less than 10? Well, here's where I deviate from many math teachers. What many math teachers have you do here is use the same formula, the a squared plus b squared equals c squared. I'll quickly do that, but I don't recommend writing this down. They go, okay, a squared plus b squared equals c squared. And the a, that could be one of the legs, so we could make it 6. And b, that'd be the other leg, so I guess that'd be x, so you could put x squared, or just keep it b squared. And then c is your 10, so you put 10 squared in there. And that can be a little confusing. You have 6 squared plus x squared, I mean that's 36 plus x squared equals 100 over here. And you know, we haven't done much solving equations yet, so you would now need to solve and isolate the x squared, and I haven't taught you about that. So I don't really do it this way. Here's what I do. If you're finding the hypotenuse, like in the question up here, what did you know about the answer even before I did the question? You knew before I did anything that it was going to be the longest side. It was going to be more than 6 and actually even more than 7. And why is it we ended up with a number that was more than the 6 or the 7? It's because of this plus right here. That's what ended up with a number more than 7 because we added. So I'll just make note of that. If you're finding the hypotenuse, you're going to square the numbers and add, just like we did. Now, in this question, the new question, we just said we know our answer is going to be less than 10. It's going to be less than 10. So you're still going to square them, but you want an answer that's smaller. So guess what you're going to do? You're going to square the numbers and subtract this time. Okay? So when you want to get a bigger number, you want to get the hypotenuse, you're going to add. When you want to get a smaller number, you want to get one of the legs, you're going to subtract. And the last step that you will always do is you'll do that square root, just like we did up here when we took the square root of 85. Alright, so let's do this question now. It's actually not that much different. I'm going to skip the equation now. You won't see me writing the equation very much for Pythagorean Theorem anymore. Because here's what I do. I recognize it's going to be the Pythagorean Theorem. I know I'm going to do some squaring of numbers. So I already know the longest side, which means I'm going to have to subtract to get a smaller number. So I'm going to square the 10, square the hypotenuse. I'm going to square the 6. I'm going to subtract those two answers, and that's equal to x squared. right? Everything's got to be squared, but because we're going to get a smaller amount, we're going to subtract. Then we just do the same thing. 10 squared is 10 times 10, or 100. 6 squared is 6 times 6, which is 36. Keep this the same. Don't write 64 here. Keep it the same, just x squared. Now, go 100 minus 36, which is 64, equals x squared. I mean, it's ridiculous to think this is 64 because it's such a big number, but also we know it has to be less than 10. So this cannot be right. What have we forgotten? We haven't done that last step yet. We haven't done the square root. So the square root of x squared, the squared and the square root cancel each other out, so you're just left with x, and the square root is 64. Oh nice, that's a perfect square. What number multiplied by itself gives 64? 8 times 8 gives 64, so x equals 8. We now know that this side here is 8, and that makes sense. It's smaller than 10, but not outrageously smaller, so I feel good about that. Okay, so this is the only thing really new today, is just being careful about whether you're going to be adding or subtracting. So I think this one as well is pretty well the same, isn't it? We know the hypotenuse. Here's the hypotenuse. Across from our right angle is the hypotenuse. This is the longest side. So when we're looking for this side, we're looking for something smaller. Should you be adding or subtracting? Well, if we're looking for something smaller, you should be subtracting. So I'm not going to write down the formula. I'm just going to take the hypotenuse and square it. And because I'm looking for something smaller, I'm going to subtract the one leg we know, square that, and that'll be equal to the leg we're looking for. Make sure you square that as well. Everything's squared. Now you just go through and do this. 12 squared, that's 12 times 12, which is 144. 8 squared, that's 8 times 8, which is 64, equals y squared. 144 times 64 equals 80, equals y squared. And of course, we're going to take the square root to finish off. We always do that with Pythagorean Theorem questions. So 81 is a perfect square, which would be 9. This is just a tiny bit less, so it must be like 8.9. Should I even check it? Oh, what the heck. This is me checking my answer now. Yes, in fact, it almost rounded up to 9.0, but 8.9 is your answer. Looks good, makes sense. Off we go. So one new thing is a Pythagorean triple. So what that is 3 positive numbers, no negatives. 3 positive numbers, we'll call them a, b, and c, such that a squared plus b squared equals c squared. Oh, it's just 3 numbers that if you put them into the Pythagorean theorem, they actually work. Okay, I've messed up this question, so I've fixed it on your sheet, I think. It should say, find the missing value of 2 parts of a Pythagorean triple are 24 and 25. And then you also need this information, because if I didn't give you this information, you wouldn't know, is this the a and the b, and we're looking for the c? In which case it would actually look like this, 24, 25, and you find the c. That's not what we're doing here. We have this situation right here, and you can see the spaces in the first one. So that's the a. We're looking for the a. So this is not correct. This is not a and b. This is b and c. So if this was a triangle, for example, because it kind of is like a triangle, this would be your hypotenuse, wouldn't it? Alright, so that might be a hint about what you're going to do if that's kind of the hypotenuse, and we're looking for a smaller number. We're going to subtract, aren't we? But I'll follow through with this. Again, it gets a little confusing, but hopefully you can see, oh yeah, since I know the c value, I'm going to square them both and subtract. I would just go ahead and do that. But I will do it with plugging into the equation. So we don't know a, so we have a squared, plus b. b is 24, so we have 24 squared, equals c squared. c is 25, so 25 squared. So leave the a squared, plus 24 squared is 576, and 25 squared is 625. Now again, we haven't done any solving equations yet, but what you want to do is you're going to get rid of this 576, and what you do to one side, you do to the other as well. So maybe you've seen that sort of thing before. That will be gone. If we have 576 and subtract 576, there's nothing left there, it's just 0. But we still do have the a squared on this side. And on this side, 625 minus 576 is 49. Now, that's not our number, of course, because the last step always is take the square root. Square root of a squared and square root of 49. Well, the square root of a squared, the square root and the squared cancel out. You just have a, and the square root of 49 is 7. We did it. We found our answer. A Pythagorean triple, one example of one, is 7, 24, and 25. 3 positive numbers and if I put them all into these spots, it'll work perfectly. Again, what I probably would have done right away is just notice, oh, this is my C value right there, so I'm going to square that one because it's like the hypotenuse, and subtract, square the other one, and then put my, I guess I was looking for A squared, and follow along like that. That will give you exactly the same answer. That's 7 right there. Alright, hope that makes sense, and let me know if it doesn't, because I am here to help you. Goodbye.